Good morning, sir.
Good morning, sir.
Good morning. Good morning. Good morning. So, can someone, what were we discussing last week? Can someone try to recap that one? That thing?
So we discussed how to find out the area of triangle using sum of consecutive numbers.
Yeah. And how did we do that? How did we get sum of consecutive numbers for area of the triangle? Good morning, Sachin.
So we have to make small squares in that triangle.
Yeah. Yeah. We make small tiles. Yeah. Good morning, Priyadarshini. So what did we do? We took a one. So we have a triangle which is 1 by 1. Base is 1 and height is 1. So what did we do? We took a square which is 1 by 1, broke it into small tiles. How did we break it into small tiles? What did we do to break it into small tiles? A 1 by 1 square. Does someone remember? What did we do? We broke it into small tiles. A single square, a 1 by 1 into small tiles. How did we break it into small tiles? Anyone? Who remembers how we broke a 1 by 1 square into small tiles? Okay, let me ask a random person. Anyone wants to raise, or should I ask a random person? Okay, let me ask Akash. Akash Jakati, are you there?
Yes, sir.
Yeah. Do you remember how we were? So we had a square, 1 by 1 square. Okay. And we were breaking that square into small pieces, small tiles. How did we do that? Do you remember? Don't remember? Okay, let me show. Yeah. So do you remember how we were breaking into small tiles? What did we do? What did we do to break it into small tiles? What is being shown here? This is a 1 by 1 square. How are we breaking into small pieces? Akash, we are
100
dividing it. Yeah, sorry, go ahead. Priyadarshini, yeah, okay. Priyadarshini, you can answer.
We are dividing it into two equal parts.
We are dividing it into what? Come again?
Two equal parts.
Wait. So two equal parts to get we are trying to find the area of the triangle, but we are trying to get it by counting these small tiles. Is that right?
Yes, sir.
So we are not doing it by that method. We're not doing it by the method that, there is this triangle and this triangle, and so I'll just take half of that. I'm just actually counting those tiles in the triangle. But how am I getting these small tiles? What did I do? I divided each side into small. Like I made 100 by 100. Like I made hundreds by 100. So 10,000 small tiles I made. Right? Each tiny square here is 100 by 100. Okay, so there are 10,000 tiles here. And when we make 10,000 tiles, then for the triangle, how many tiles are there in the triangle? How do we count the number of tiles in the triangle? So we have broken a 1 by 1 tile into 100 this
One
way and 100
divided
this way.
by
Yeah, sorry, go ahead. Who was talking?
so we are dividing one by the total number of tiles and making it a square.
Yeah. So total, how many tiles are there? So let's say it's 100 rows this way and 100 columns this way. So total how many tiles are there?
10,000 tiles.
10,000 tiles, yes. And in the triangle, how many tiles are there?
5,050.
How do you get 5,050?
No, sir. 5,000, sir.
So the number of how do you get 5,000? Tell me how you get 5,000. So remember, we are counting triangles like this. Okay, we are counting, like this one. So we are approximating the triangle by these steps. Okay, and then we're counting 1 tile here, 2 tiles here, 3 tiles here, 4 tiles here, like that. How much will it be?
5,050.
So 5,050.
How do you get
5,050?
5,050? Exactly. So we are adding 1, 2, 3, 4, all the way to 100, and we're getting 5,050. But the area of each tile is how much? So is the area of all the tiles under the step, is it 5,050 or it is less than 5,050?
What, sir?
What is the area of all the tiles under the steps? How much is the area of the tiles under the step? What is the area of all these triangles here? Like this area of these all the triangles which are under the the red squares, the red tiles. Pretend this is 100, this is 100. What is the area of all the red tiles? So I'm marking all these tiles as red.
0.0001 into 5,050.
Sir, we
Exactly.
get
How much is that?
0.505, sir.
Exactly, 0.505. Okay. So by dividing a square into 100 by 100 tiles, that is 10,000 tiles, we get approximately the area of the triangle to be 0.505. Now, is this exactly the area of the triangle or it is approximately of the area of the triangle?
Approximately, sir.
Why is it approximate?
Not exactly.
Why is it approximate? Why is it approximate and not exact? Why is it coming out to be more than the area of the triangle? Yeah. Why is it coming out to be more?
So there are some half triangles, sir.
Yeah, exactly. There are these extra. So the actual triangle is like this, and you have these little half triangles. Okay, so you will have actually 100 half triangles. Because you have 100 half triangles, you get, that's why this 50 half triangles extra. That's why instead of 5,000, you get 5,050. Okay. So Akash, Jakati, do you understand this part? So far, why we get, how we get approximately the area of all the tiles below the steps, and how that is approximately the area of the triangle, and how that way we get 0.505. Do you understand that, Akash?
Yes, sir.
Next, what were we doing last time? So we tried 100 by 100 and we got this answer. And then what did we say? Let's make it even. Yeah, what did we say? Does anyone remember?
Billion of small squares.
Yeah, so million by million. So actually million times million. Million times million is how many zeros? 10 to the power what? How many small tiles will we get if this is million by million? Instead of 1,000 by 1,000, if it is million by million, then how many small tiles will we get? 10 to the power how much? What is the total number of small tiles?
So 10 to the power of 12.
10 to the power of 12, sir.
10 to the power of 6, sir.
So 10 to the power of 12.
10 to the power of 12, sir.
Who said 10 to the power 6? How did you get 10 to the power 6? So it will be 10 to the power 12. Why? Because the number of such tiles will be million times million. Okay, the number of rows is a million and the number of columns is million. So million times million, and million is 10 to the power 6. And so million times million is 10 to the power 6 times 10 to the power 6, which is 10 to the power 12. Okay. And now how do we get so if we use million by million, then how do we get the area of all the tiles under the steps? How do we get that? We use, can someone explain this? What are we doing here? Yeah, can someone explain this? What are we doing if we get a million by million? Now we'll get something even better answer than 0.505. Why? Because if you take tiny pixels, if you take like million by million small things, then that area under the step will become almost like the area of the triangle. So how much will it be? So tell me, how will you get the area of all the tiles under the steps? Can someone explain that?
Sir, area of each square into number of tiles under the
Blue tile.
Exactly. Yeah. Now, can tell me why this is the formula for that? See, you see my mouses. Where is my mouse? Can someone tell me why?
Sir,
What is the which part? Yeah, go ahead.
Sir, we divide the whole square into 100 into 100 square, sir.
Million by million. Earlier it was 100 by 100. Now we have changed it to million by million. Even make it smaller and smaller squares. Smaller and smaller tiles. Okay. So now someone tell me the formula for the area of all the tiles under the steps.
N bracket N plus
Sir,
1
we have
divided by
to sir, we have to multiplicate the area of one tile. So 1 by 1 million whole square into number of tiles under the blue steps, sir.
Exactly. So think that n is equal to million. Now tell me the formula in terms of n. Okay. So n is a million. Now tell me what is the area of the each tile? How much is it?
1 by n whole square.
Yes. So do you see this here? What do you see this here? This caret symbol, think that it is to the power, because I'm not able to draw to the power here. So this thing, this is 1 by n whole square. Okay. You see my mouse here?
Yes,
Can
sir.
everyone
yes,
see this mouse here? Yeah. So this is 1 by n whole squared. Okay. This is the area of each tile. And which part is the number of tiles? Can someone tell me where is the number of tiles here written in this equation here?
N bracket n plus 1
Sir, n
divided by
bracket n plus 1 divided by 2.
divided by 2, sir.
Exactly. So this 1 by n whole squared times n plus 1 by 2 is the area of all the tiles under that steps. Now tell me, if you simplify this, what do you get? What do you get if you simplify this?
500,000, sir.
No, first just simplify without substituting n. Let's just cancel out then. If you cancel out the n, what do you get? Tell me a simpler version of this formula. It's written right here actually. Can you read out the simpler simplification of this formula?
1 by n square into n square plus n divided by 2.
1 by n squared into
N square plus divided by 2.
Okay, now simplify it more.
1 by 2 bracket n plus 1 divided by n, sir.
Yeah, this one. Okay, half multiplied by n plus 1 by n. Actually, let me just write it by pen. Half into n plus 1 by n. Okay. Now tell me what happens when you put. Can someone tell me why this is very close to half? If n is a million, why is this very close to half?
So number of tiles under the blue line is like the half of the whole square.
No, that is true. But why is this? Don't look at that method. Look at, we are not pretend that you don't know. You're not using geometry. Okay, you're just using this formula. In this formula, half into n plus 1 over n. Why is this very close to half? For n is a million. Think about n plus 1 divided by n. N plus 1 divided by n when n is a million. What happens when n is a million? Is this close to something? What is this close to? Look at this n plus 1 divided by n. When n is 100, what is this? Just this part, okay? Just ignore the half. Let's remove the half. Just think about n plus 1 divided by n. What happens to this when n is
1.014.
Yeah, when n is 100, it is 1.01. Yeah, when n is million, what is it? When n is million, what is it? As n gets bigger and bigger, this gets closer to what? 1.01 is close to what? What is 1.01 close to?
1, sir.
Yeah, it's close to 1. And if you take n equal to a million, then is it even more
Sir,
close
we
to 1?
get 1.
How many zeros?
Sir, 5 zeros.
Sir,
5
5.
zeros, sir.
5 zeros. Yeah.
Sir.
So when it is a million, you get 1.5 zeros and 1. Okay.
Yes, sir.
What about a billion? Then how many zeros will you get?
7, sir.
Yes, Madhumata.
7.
7.
7, sir.
Wait, billion is actually 10 to the power 9, right? And 1 over 10 to the power 9 will have, is it 7 zeros or is it 8 zeros?
8, 8.
8 zeros, sir.
8, sir.
8 zeros. Yes.
8
Okay.
zeros,
Now
sir.
can someone tell me why this gets close to 1 as you make n bigger and bigger? Can you write this in a different way so that it becomes very close, that it's clear it is 1 plus some very small thing? If I remove 1 from this, how much will I get?
1, sir.
1, sir.
1, sir.
Is this exactly equal to 1? Is this exactly equal to 1?
Yes, sir. N by y.
Yes,
N.
Yes, sir.
1.
Yeah, repeat that, sorry.
N by
Repeat
1
that.
is equal to 1.
N by n.
N
is
by
equal
n
to 1.
is equal to 1.
Yeah, so this thing is equal to what? What is n plus 1 divided by n? This is equal to how much? What is it? Is it exactly 1? Should I write 1 here or something else?
No, sir.
No, sir.
Yeah, what is it?
1 more
What is
than
it?
1.
1 plus? Yeah, how much more than 1? Simplify this, n plus 1 divided by n. How much is it? What is n plus 1 divided by n? How much is it? Is it 1?
One by n, sir.
Yeah, tell me again. What is it exactly? N plus 1 divided by n is equal to?
1 plus 1 by n.
1 by n, sir.
Yeah, 1 plus 1 by n. Okay. Because I just write this as n by n plus 1 by n, which is 1 plus 1 by n. Okay. Now, do you see what happens to 1 by n as n gets bigger and bigger? So when n is 100, this becomes 0.01. When n is a million, it becomes 0.7 zeros and then 1. N is billion, it becomes 0.8 zeros and 1. Sorry, when it is million, it becomes 5 zeros and 1. And
5
it becomes
zeros,
more
sir.
and more. Sorry, repeat that. Yeah. Who said someone said something? Can you repeat that? So when n is million, then it has after the decimal, the 1 is in the 6th place. So it's 5 zeros and 1. Billion, it gets even more zeros. Then trillion becomes even more zeros. So as you make the number of tiles more and more small, let's say you have a very high resolution camera, you have a very high resolution screen, then what happens to this 1 over n? It becomes, what happens to this? When you're trying to get the area of the triangle by making it smaller and smaller tiles, then what happens to this 1 over n? We already saw that when n was 100, it was 0.01. Then when it was a million, it was 0.000001. Then billion, it became even smaller. So if you make it more and more small, then this will become, how much will this become, this whole thing? When n becomes very large. Let's say I make n is like, 10 to the power 100. That many small tiles. Then how much will this become? How small is this when n is 100? When n is 100? N is 10 to the power 100. And how small is this? How much is this 1 over n when n is, okay, let's take n equal to 10 to the power 100. Okay, so 10 to the power 10, there are 100 zeros after 1. Then what is this? What is 1 over n when n is 10 to the power 100? Someone wants to tell? Anyone knows what happens when I may take n like that many large number of tiles? 10 to the power 100 rows and 10 to the power 100 columns. Then what is this n plus 1 divided by n? It is 1 plus 1 over n. What is this 1 over n? How much is this 1 over n? What is 1 over 10 to the power 100? Anyone knows what is 1 over 10 to the power 100? No one knows what is 10 to the power 100? 1 over 10 to the power 100?
1, sir.
So 10 to the power of minus 100.
Yeah, who answered 1? 1 divided by 10 to the power 100 is how much? Someone answered 1. Can someone say why it is 1?
Sir,
Yeah, raise your hand. Whoever wants to speak, just raise the hand. Okay, Sahana, how much is it?
sir, I get 0.1 to the power of 100, sir.
Yeah. You can also say that as 10, 1. You can also say that is 10 to the power 10 to the power
Minus
what?
100, sir.
Minus 100, sir.
Yeah, 10 to the power minus 100. Is that small or is that big? What is that? What is 10 to the power minus 100?
Sir, small.
How small is it? If you write it in decimal 0.00, how many zeros will you get like that? If you write it in decimal, what will you get? What is 10 to the power minus 100? How small is it? If you write it in decimal, what will you get? 0.0000. How many zeros will you get?
Sir, 0.99 zeros and
99 zeros and 1, sir.
Yeah, correct. You'll have 99 zeros. 99 such zeros. Okay. So is that very, very small?
sir.
Yes,
Sir.
very small. Yeah. So then this will become, if I have 10 to the power 100 by 10 to the power 100 tiles, then this will become 1.0000, like 99 zeros and then 1. And if I make 10 to the power 200, then it will become 199 zeros. So it will become very, very close. This will become very close to what? The more resolution I make, the more I make smaller and smaller tiles, this will become how much? It becomes closer and closer to?
Closer to area of the triangle.
Actually, remember the area of the triangle was half of n plus 1 divided by n. I've ignored the half. Okay, I'm ignoring the half here. So I'm just looking at this quantity, n plus 1 by n. Okay. So the actual area is half of this. But this quantity will become close to what? As I make n 10 to the power 100, then 10 to the power 200, 10 to the power 300, like very, very small tiles. Then this quantity, this n plus 1 divided by n will become what? Closer and closer to? How much? Which number will become close? Become close to which number?
0.
Sir, it is closer to the area of square. Area of square,
Yeah,
sir.
yeah. I'm saying what number it will become. How much it will become?
0.
Close to
Nearer to the 1, sir.
0.
yeah. Who said 0? Is n plus 1 divided by n will approach 0? What will become 0? Will n plus 1 divided by n become close to 0? Yeah. Who said 0? Can someone raise the hand? Who said 0? How much will this get closer and closer to? As I make n bigger and bigger, so I started with n equal to 100. Then I made it million. Okay. And then I made it billion. And then I made it 10 to the power 100. Then I made it 10 to the power 200, 300, like that. Very, very, very big numbers. And I get 1 plus 1 over n.
It is near
One over
to
n.
0.
Okay, who said that? Can someone raise whoever said that can raise the hand? Okay. Okay, Farhan. So just repeat what you said. What will become near to 0?
10 raised to 1 raised to power 200. Sir.
Wait. Just once more repeat. What will become near to 0?
1 by 10 raised to 100 and 200.
Yeah, 1
It
over
is
10
near
over 100
to
will become exactly. It's become near to 0. It is not exactly 0, but it's near to 0. Especially if we make it 1 over 10 to the power 200, it will become even more near to 0. If we make 1 over 10 to the power 300, it becomes even more near to 0. So how much will n plus 1 over n become? Near to how much? n plus 1 over n become near to how much? Farhan?
Sir, repeat the question.
So as n becomes large, if you put n equal to 10 to the power 100 and then 10 to the power 200 and so on and so forth, then n plus 1 divided by n will become near to how much?
1, sir.
Okay, Farhan, can you answer?
1, sir.
Yeah, why is it 1?
Sir, in formula there is plus 1.
Yeah. So n plus 1 over divided by n is 1 plus 1 over n. And for large n, when you make n equal to 10 to the power 100, 10 to the power 200, then this becomes nearer and nearer to 0. So so this whole thing becomes near 1. Okay. But the area of the triangle was not n plus 1 over n. It was actually half of n plus 1 over n. Okay. So then what happens to, if I take half of this, okay, then I get half of 1 plus 1 over n. How much is that? Close to? How much will that become as n becomes larger and larger? What is half? What happens to half of n plus 1 over n?
It became
What
half,
happens?
sir.
It becomes close to half. Okay.
Yes, sir.
So can someone repeat now what all we did? How did we get that so when you make the tile smaller and smaller, then the area of the triangle becomes close to half. So now can someone recap what we did? How did we use sum of consecutive numbers to get area of the triangle? We broke the 1 by 1 square into small tiles, n by n tiles. Okay. So total n square tiles. Now can someone recap how we got that the area of the triangle is close to half? Who wants to recap what we did? Anyone wants to repeat what we did and how we got the area of the triangle? Okay, Pooja. Did you raise your hand, Pooja? Who wants to recap how we got the area of the triangle close is half? Or it becomes close and close to half if we make more and more small tiles. Who wants to repeat the steps that we did? Anyone wants to repeat the steps? First, we divided the 1 by 1 square into small rows, small columns, and we did n by n. So first we took n equal to 100, then we took n equal to million, and smaller. So we took n by n. In general, we take n by n. Then what did we do with it n by n? Just look at this page. Someone wants to recap this? Who wants to recap this? Anyone? I can help. Don't worry if you're not able to figure it out. I can help. We found the area under the steps. How did you find the area under the steps? Okay, let me pick one person. Okay, Aishwarya, can you tell? Okay, wait. I see some hand up. Mahalakshmi, do you want to say? I see a hand up. Do you want to say what we did? Mahalakshmi?
Sir, we have to find the area of each square, sir, by multiplying the area of each square into number of tiles under the blue steps, sir.
Okay. And how much was the area of each square? Yeah, how much was the area of each tiny tile?
We divided the whole square into n by n, sir. So the area of one each square is equal to 1 by n whole square, sir.
Yes, it's 1 by n square. And then what was the total number of tiles under the steps?
N by n plus
n
1
bracket
divided by
n plus 1 whole.
Yeah, n into n plus 1 by 2. So we got 1 by n squared multiplied by n into n plus 1 by 2. And then we simplified that and we got half times n plus 1 by n. Okay. And then we further simplified that and we got half times 1 plus 1 over n. Okay. And now tell me, what did we do after that? After we got half times 1 plus 1 over n, what did we say? That if n becomes big and more big, okay, 100 and then million and then billion and then 10 to the power 100 and so on and so forth, then what happens to this 1 plus 1 over n? What happens to that? How much this has become? What happens to this 1 plus 1 over n?
So it is near to 1.
Yeah, it becomes very close to 1. When n is like 10 to the power 100, then it is 1.000000, like 99 zeros and then 1. When n is 10 to the power 200, then it is 1.000199 zeros and then 1. So it becomes very close to 1. And that's why half of that becomes very close to half.
Very close to
So
half.
did everyone, yeah, so did everyone understand why we can, how we can use this 1 plus 2 plus 3 plus 4 like this to get the area of the triangle? Did everyone understand that part?
Yes, sir.
Who did not understand? Is there someone who did not understand? Anyone did not understand?
Sir, how 1 plus 1 by n is nearer to 1?
Okay. Who spoke? Can the person raise the hand? Okay. Sahana. Okay, Sahana. So your question is, why is 1 plus 1 by n close to 1? Is nearer to what? Repeat your question.
Sir, 1.
Repeat your question. Yeah, why is it close to 1? So tell me what happens. What happens to this when n is a million? How much is this? Okay, so let's write here. 1 plus 1 over million. Okay, how much is this? 1 plus what? How much is 1 over 10 to the power 6?
10 to the power of minus 6.
Yeah. If I write down in decimal, how much will it be?
Sir, 0.501, sir.
0.
Yeah, exactly. Okay, so it is 1.0000001. And now if
Sir.
I make, instead of 1 over 10 to the power 6, if I make it 1 over 10 to the power 100, then what will happen? How much is this? Sahana, how much is it?
0.9901.
1 plus
99 zeros.
Yeah, 99 zeros and then 1. Okay. Yeah. So Sahana, how close is 1.00001 to 1? What is the difference between that and 1? How much is the difference between those two things?
what, sir?
How close is this? If I take 1.99 zeros and then 1, how close is that to 1? Is it very close to 1 or is it far from 1?
Yes, sir, it is very close to
Very
1.
close to 1.
Very close to 1, sir.
Close to the
Yeah. And what happens if I take 1 over 10 to the power 1000? Then will it become even more close to 1?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
Sahana, do you see that? Do you understand that?
Sir, I understood.
Okay. So that means this part 1 plus 1 over n becomes very close to 1 as you make the number of tiles, as you make the resolution of the tiles smaller and smaller, like higher and higher resolution. So you make the tiles smaller and smaller, then they become very close to 1, and this becomes half times 1 plus 1 over n. Okay.
Yes, sir.
So is there anyone who did not understand why this becomes close to half? Anyone who did not understand this part? Yeah, Naveen, go ahead. Yeah, what is the question? Yeah, Naveen, go ahead. Tell me which part you're not clear about.
Half of n plus 1 divided by n.
Okay. So half, let's look at this n plus 1 divided by n, okay? So it is half times, what is n plus 1 divided by n? How much is it? I can also write it as 1 plus
1 plus 1 by n. 1 plus
1 by n.
1 plus 1 by n. So Naveen, now tell me what happens. What is 1 plus 1? What is 1 by n when n is 10 to the power 100? What is 1 by n? How is it small, or is it very tiny, or is it big? Naveen, how much is what happens to 1 plus 1 over n when n is a million? How much is 1 plus 1 over n when n is a million? Naveen, 1 over 10 to the power 6.
0.601.
5 zeros actually. Okay, it will be 5 zeros.
0.501.
Yeah. Okay. Is that small or is it big? Is that a small number or is it a big number?
Small number.
Yeah. Now if I take 1 over 10 to the power 100, okay, if I take n equal to 10 to the 100, then
0.9901.
yeah, will it become even smaller or will it become bigger?
It is
What
smaller.
happened to it? Smaller, yes. 0.99 zeros, more and more zeros in that one. Okay. So now tell me what will happen if I take 1 plus 1 over 10 to the power 100.
1 plus 0.9901.
Yeah, exactly. It will become 1.00, 1.0000, lots of zeros in that one. So it's very close to 1. Very close to 1, correct?
Yes, sir.
So now if I take half of 1 plus 1 over 10 to the power 100, it will become very close to how much? Half of
Half.
this. It will become exactly this number.
Half.
Yeah, it will become very close to half. It will become half plus like 0.00001, half of that. Okay, so that extra amount from that half is very small. It's very small. It's actually 0.100 zeros and then a 5. So it is half plus 0.100 zeros and then a 5. So Naveen, this thing is very close to half.
Half.
Did you understand this part? Why it is very close to half?
Yes, sir.
Yeah, because that you get half plus like 0.00001 divided by 2, which is like 0.99 zeros, like 100 zeros and a 5. Okay, if I take 0.99 zeros and then 1 divided by 2, I get 0.100 zeros and a 5. Understood, Naveen? Why this becomes very close to half?
Yes, sir.
Anyone else who did not understand? Is there anyone else? Everyone understood, or if someone is not clear? We got n columns, n rows, and then we counted the number of tiles under the steps. The number of tiles was 1 plus 2 plus 3 plus 4 till n, which is n times n plus 1 by 2. That is the number of tiles. And the area of each tile is 1 over n squared. So we get 1 over n squared times n plus 1 by 2. And if you simplify this, you get half of n plus 1 by n. And if you simplify that more, you get half of 1 plus 1 over n. And this 1 over n becomes very small. As n becomes more and more big, then this becomes more and more small. And this whole thing becomes close to 1. And that's why the area is half. Anyone else who did not understand? Anyone did not understand? Anyone did not understand? Who found this part very hard? Who found it easy? Who found it not difficult? And who found it difficult? This part. Finding the area of the triangle like this. How many people found it not very difficult? How many people found it difficult? Okay, just say, did you find it difficult? Then just say yes. Then I'll be able to figure out how many people found it difficult.
Yes, sir.
Okay. Now let's go to a slightly harder question. Okay. So far we were talking about area of a triangle. Okay. Next we will go to something more complicated. We'll go to volume of a cone. Okay. So let me draw a cone. Okay. So how do you get a cone? You can get a cone from a triangle. How do you get a cone from a triangle? Can someone say how you get a cone from a triangle? Let's say I take a 1 by 1 triangle and what do? I can rotate it. How do I rotate it to get a triangle cone? So I want a cone of height 1 and radius 1. How do I get that from a triangle? Can someone say that? Okay, tell me what have I drawn here?
Cone.
Sir,
cone.
Cone.
Okay. So what is the radius of the cone?
1, sir.
1, sir.
1.
1.
And what is the height of the cone?
One.
Height of the
One,
cone?
sir.
One,
One.
sir. One, sir.
But I've put the cone not vertical. I've made it horizontal. Okay. So this is now actually I've not drawn it to scale. So this is now the triangle. Okay, the triangle that we were showing before. You know this triangle. Yeah, you see this triangle. This triangle.
Yes,
That
sir.
is same as this triangle here. It is same as this triangle here. Okay. And now what did I do the triangle to get the cone? What did I do to the triangle to get the cone? How can I get the cone from the triangle? Can I rotate
Draw
the triangle to get the
circle.
cone? Yeah, you draw, but can I rotate it? Can I rotate a triangle to get a cone?
Yes, sir.
Yes, sir.
Okay. I rotated it around which axis? Did I rotate along this axis, the horizontal axis, or the vertical axis? Which axis did I rotate along?
Vertical
Vertical
axis.
Vertical axis.
Vertical axis. Vertical axis.
This is the vertical axis. Did I rotate it along this one to get this cone? Or did I rotate it along
Yes,
the horizontal
sir.
axis too?
Yes, sir.
Yeah, which one? Horizontal or vertical? Which one did I rotate?
Vertical.
Vertical is
Vertical, sir.
If I
Vertical, sir.
rotate it around the vertical axis, okay, then I'll be rotating it like this. Okay, so this is the vertical axis. I'll be rotating it like this. Then will I get the cone to be vertical or will I get it horizontal?
horizontal.
Yeah, but this cone is it horizontal or vertical? This cone is
Horizontal.
horizontal or vertical?
Horizontal. Horizontal, sir.
Horizontal. That means I've rotated it around which axis? Have I rotated around this
Horizontal
axis?
axis.
Horizontal axis.
Exactly. I've rotated around the horizontal axis. Okay. Now, this is the triangle. Okay. But now this is the square. This was the 1 by 1 square, right? Now, if I rotate the 1 by 1 square around the horizontal axis, what will I get? If I rotate the whole square around this vertical axis, what will I get?
It will be
Sir, repeat.
rectangle.
Cylinder, sir.
Repeat that.
Cylinder, sir.
Cylinder, exactly. Okay. So if I rotate the 1 by 1 square around the horizontal axis, I will get a cylinder. So I will get something like this. Okay. So I'll get this cylinder, right?
Yes.
So
Yes.
what is the volume of that cylinder?
PR square, sir.
How much is it?
Yes.
PR square.
Volume of the cylinder. Tell me the formula for the volume of the cylinder.
Sir, pi r square h, sir.
PR square into height, sir.
Pi r square h, sir.
Yes. Sir.
Yeah. Okay. So here, what is R?
Half of 1, sir.
1.
Half of 1? Or is it 1? What is it? What is the radius here?
That is 1.
1.
Yeah.
1, sir.
It is 1. Okay. So what is the volume of the cylinder? How much is it?
Sir, pi.
Pi, sir.
Pi, sir.
Yes. Exactly. So it's pi. Okay. So what I've written here is pi times r square times h. So it is pi. Okay. And now tell me what is the volume of this cone?
Cone, sir.
Of the cone. Is it going to be less than the volume of the cylinder?
Yes, sir.
Is it going to be half of it? So volume of the cylinder was pi. What is the volume of the cone?
Volume of cylinder is pi r square h, sir.
Yeah. So volume of the cylinder was pi r square h, and r is equal to 1 and height is equal to 1, right? Because this r is 1, the height is 1. So you get pi times 1 square times 1, which is pi. Now I'm asking what is the volume of the cone?
1 by 3 pi r square h, sir.
Okay. So it is going to be how much? So is it half of the volume of the cylinder or is it less than that?
Less than.
Less than.
Yeah. How much is it? It is 1/3 of the volume of the cone. So volume of the 1/3 of the volume of the cylinder. So volume of the cone is,
Less than half.
yeah, it's less than half, exactly. So it is 1/3. Okay, so now you know this because you know the formula for the cone. Do you know why it is 1/3? Why is it not half? So when we were looking at the area of the triangle was half of the area of the square. You remember this? So this area of this triangle here was half of the area of the square, right? But when you rotate this triangle to get a cone, when you rotate the cylinder to this square to get a cylinder, now suddenly the area of the volume of the cone becomes 1/3 of the volume of this, 1/3 of the volume of the cylinder. Why does it become 1/3? Can someone tell why does it become 1/3? So can we use what we did? What did we do? Why is it not half? Why is it 1/3? Does someone have any ideas how to get the volume of the cylinder of the cone? By adding small. So what were we doing there? We were adding small tiles, right? We were adding to get the area of the triangle. We were adding these thin strips. What were we doing? We were adding, like 1, 2, 3, 4, 5, these little things, right? So by adding these things, we were getting the area of the triangle. 1 plus 2 plus 3 plus 4. Here it was just 6. So suppose that was 6, then I'm just adding this 1 plus 2. Can I do something now to get the area of volume of the cone? What will I need to add? Just look at this figure. Can someone use some idea to add up things to get the volume of this cone, approximately? So just think that we are dividing into 6 by 6 tiles, like the 6 by 6, and we're just rotating this thing to get the cone. Does someone have any ideas how to figure out the volume of the cone like this?
The cone acquires 1/3 of area in this square.
Cone acquires 1/3 of the area. No, not the area. The cone volume of the cone is 1/3 of the volume of the cylinder. When you when you rotate the square, you get a cylinder, and when you rotate the triangle, you get a cone, and the volume of that cone is 1/3 of the volume of that cylinder. But why is it 1/3? I mean, how do you know it? You know it is 1/3 from the formula. Now we are trying to understand why that formula is true. Okay, so pretend that you don't know why. Suppose nobody told you the formula, let's say, for the cone. Then why is the volume of that cone 1/3 of the volume of the cylinder? Can we use that idea similar to 1 plus 2 plus 3? We were using 1 plus 2 plus 3 by adding up small numbers, right? We were getting the area of the cylinder of the triangle. Can we use something like that to get the volume of the cone? Okay, so I see you have another class. So let's close for today. But think about this part, okay? Think about how do if I rotate this red part, if I rotate this this square, then I will get a cylinder, and the red part rotating will become like a cone. Now think how will you get the volume of that cone by adding up small things. Okay, let's close for today. Thanks. Bye.
Bye, sir.
Bye, sir.